So here, now we just say for this case, okay? For this case, plus infinity plus or minus plus infinity plus or minus infinity. For this one, we have 8 cases. We have 8 cases. In this 8 case, we have four indeterminate form. Okay, we have 4 indeterminate form. So we give an example. We give an example for this example. For limit x approaches 0 from right. X approaches 0 from right. 1 by x minus 1 by sin x. So here for this one, okay, for this one, x approaches 0 from right. 1 by x minus 1 by sin x. So here now let's see 1 by x approaches 0 from right. 1 by x approaches what? Infinity? Plus infinity or minus infinity? Plus infinity, yeah. So and 1 by sin x approaches 0 from right. 1 by sin x approaches what? Is also plus infinity, yeah. So here the plus infinity minus plus infinity, yeah. So plus infinity minus plus infinity. So here is indeterminate, yeah, indeterminate form. So for this one, so how to compute this limit? How to compute this limit? So here first, make them have the same denominator, okay? So here equal to limit x approaches 0 from right. So here x times sin x. Here is sin x minus x, yeah? Minus x. So here we can see here where x approaches 0, this is 0 minus 0, so the numerator is 0, yeah? So the denominator is 0 times 0, so here is 0 by 0. 0 by 0, so here we can use the L'Hopital's rule, yeah? The L'Hopital's rule equal to what? Equal to limit x approaches 0 from right. So here is sin x minus x prime. X times sin x prime. Yeah? So here equal to what? Equal to limit x approaches 0 from right. So here the first this limit is what? Sin. So here is cosine x. Yeah? Minus x prime is 1. Yeah? So cosine x minus 1. So here is what? Here is x times sin x prime. So here is x prime. X prime is 1. 1 times sin x plus x times sin x prime. Sin x prime is cosine x. Yeah? So here we can see when x approaches 0, so cosine x approaches 1. 1 minus 1. So here is 0. Yeah. So here this is 0. So here is sin 0 plus 0 times 1. So here is also 0. Yeah. So here 0 by 0. So it's an indeterminate form. Yeah. 0 by 0. So we can use L'Hopital's rule again. So here equal to what? Equal to limit x approaches 0 from right. So here is cosine x minus 1 prime divided sin x plus x cosine x prime. So here equal to what? Equal to limit x approaches 0 from right. Cosine x, here this prime is what? Minus sin, yeah? Minus sin. And this is what? This is, so here is sin, is cosine x, plus, here x times cosine x prime. Here x prime is 1. 1 times cosine x. So here is cosine x plus x times cosine prime, yeah? X times cosine prime is minus sin, so here is minus sin, yeah? So here now we can see x approaches 0 from right. So here is 0, yeah? So here is 0, here is 1 plus 1 minus 0 So here is 1 plus 1 minus 0, so the result is 0. Yeah. So here we use twice. We use locus rule twice. Okay. So for this one. So here actually we have another indeterminate form. For this indeterminate form, for example, for this one, okay. For this one here is 0 to the power 0, 0 to the power 0, or infinity to the power 0, or 1 to the power infinity. So this 3, okay, this 3 is also indeterminate form. This 3 is also indeterminate form. But for this 3, okay, we have the same method. We have the same method. What's the same method? The same method is you take the ln, okay, you take the ln. For example, I give you an example, okay. For this example, for here, for this 3, okay, for this 3 means what? Means limit x approaches a, x approaches fx equal to 1, and the limit x approaches a, gx approaches infinity. So what about limit x approaches a, fx to the power gx, So what about this limit? Limit x approaches a, fx approaches 1, x approaches a, gx approaches infinity. So what about this limit? X approaches a, fx to the power gx. So here this actually is 1 to the power infinity. This one. So this one, how to define it? So how to find the limit? Actually, we have the same method. Okay. For example, for this one, I give you an example. This limit x approaches 0, 1 plus x to the power 1 by x. Now we can see this limit. Okay. This limit you can see here when x approaches 0, 1 plus x. 1 plus x is this part approaches 1, yeah? And this part, this power 1 by x approaches infinity, yeah? So this is actually 1 to the power infinity, yeah? 1 to the power infinity. So for this one, just keep in mind, okay? Just keep in mind. We give a function y equal to 1 plus x to the power x. So here we take ln on both sides. So here we have ln y equal to ln 1 plus x, 1 by x. Yeah? Yes. So here now this 1 by x we can take it here, yeah? So here equal to 1 by x ln 1 plus x. Yeah? So here now we can see, so here actually is ln 1 plus x by x, yeah? Yes. So ln y, so here we can see ln y equal to ln 1 plus x by x. So now, what about this limit? Limit, we can see limit x approaches 0 ln y equal to limit x approaches 0 ln 1 plus x by x. Yeah? You can see x approaches 0, 1 plus x approaches 1. Ln 1 is 0, yeah? Yes. So here this is 0, so 0 by 0. 0 by 0, so we can use the indeterminate form, yeah? So here equal to what? Here equal to limit x approaches 0, so this ln 1 plus x, this derivative, divided x derivative. Yeah? So equal to what? Equal to limit x approaches 0. Here, this limit, but no. This derivative is what? Is 1 by 1 plus x. Yeah? Yeah? And this limit, this derivative is 1. Yeah? So here equal to limit x approaches 0 equal to 1 by 1 plus x. So this limit is what? 1 by 1 plus x. X approaches 0. So it's 1 by 1 plus 0. So it's 1. Yeah? So here means what? Here means when x approaches 0, ln y approaches 1. So here, now, so here this limit actually is what? So this limit actually is limit x approaches 0. Here, actually, here is 1. Here is y, yeah? So here is y. Y, what's the relationship between y and ln y? What's the relationship between y and ln y? So here we know that x approaches 0, y equal to e ln y, yeah? Y equal to e ln y, yeah? So ln y approaches 1, yeah? X approaches 0, ln y approaches 1. So here this approaches what? So here this approaches e to the 1 power. So equal to e, yeah? So here, now, okay, for this one, for this 3 one, okay, just keep in mind, take the ln function. Take the ln function, okay? Take the ln function, and you can take the power out of the function. You can take the power out of the function, and then use the L'Hopital's rule, okay? So here this is all. So here we can see the first, second, third, okay? And then here we have 4. So 7. So here 8, 9, 10. So we have 10. We have 10 in determinate form. So for this, the first and the second, these two use the L'Hopital's rule. For this one, transfer it into these two, okay? And for this one, just make them have the same denominator, and then use the L'Hopital's rule, okay? And for this one, take the ln function, okay? So now, so this is all the content. Now I think that I should give you a exercise, okay? So now to the exercise.
Actually, can you just explain the ln function and where the e came from?
Yeah. So here y equal to e ln y. You can understand it. So you can, for example, x equal to 2. So x equal to what? E to the power x equal to 2. So how to find x? Take ln on both sides, yeah? So here means what? Here means ln ex equal to ln 2, yeah? Ln ex is what? Is x. X equal to ln 2, yeah? So here means what? X equal to ln 2, yeah? X equal to ln 2, so here means what? X, so you replace here this x by ln 2. So e ln 2 equal to 2. Okay? So the same, e ln y equal to 1. So now the first four, okay? So here, you the first one, the second one, the third one, four, okay? Sine waves divided by sine phi waves. So you here, the first one, the second one, the third, fourth, okay? So you put the exercise, okay? Put the exercise. Yes. So second theta, what's the definition? One by what? Second theta. So usually, yeah, do it on the blackboard. No. Second theta equal to what? 1 by cosine. 1 by cosine. 1 by cosine. So here, second theta equal to 1 by cosine. 1 yeah. Yeah. So leave it. So this is equal to what is that? 0. 1 over 1. Theta which is 0, cosine theta which is what? 1. Cosine 0, yeah. Cosine 0 is what? Yeah, 1, yeah. So here is what? 1 by 1. 1 by 1 square, yeah. So I say sine, cosine, sine 0, cosine 0, sine pi, cosine pi, sine pi. And what's the definition of second? So usually So now, you the first one. You the second one. Yeah, you the first. No, the first. It's so easy, okay? So easy. So I think that I give you time to show you to do it, okay? I give you time to do it. Of course, I will test it, okay? Of course, I will test the L'Hopital's rule, okay? So you must be familiar with it, okay? So do it, okay? Do it.
No, here's not by 0 by 0. Here is 0, here's 1 by 1, here's 0 by 1. So you use the one, you can see here is 0 by 0, it's the interval.
So I think it's easy, okay? It's easy. The first one. So x pushes 0, ex minus 1 pushes 0, yeah? So x pushes 0, say x pushes 0. So here is 0 by 0. So we use the L'Hopital's rule, yeah? So here is limit x pushes 0, this limit. The first, the numerator limit is of the derivative is what? Ex, yeah? Here is cosine x. So x pushes 0, here is e to the power 0, here is cosine 0, so 1 by 1. The result is 1, yeah? The second here is also so here, okay, here how to do it. First, you can see the first step you must to determine it indeterminate form, yeah? So here you must to limit x approaches 0 sin 2x approaches what? 0, yeah? and the limit x approaches 0, cosine, sin 5x. Sin 5x, here is what? It's also 0, yeah? So 0 by 0, yeah? So indeterminate form, yeah? Indeterminate form, so we can use the L'Hopital's rule. So here is the limit x approaches 0. Here is sin 2x prime is what? Is cosine 2x, yeah? And 2x prime. So it's 2. So 2 times cosine 2x, yeah? And here this part, sin 5x prime is what? Is cosine 5x, yeah? Cosine 5x. And 5x prime is what? Is 5, yeah? So here is like this, yeah? So limit x approaches 0, this part is 2 times cosine 0. Cosine 0 is what? Is 1, yeah? 5 times cosine 5, cosine 0. So here is 5 times 1, yeah? So the result is 2 by 5, yeah? 2 by 5, yeah? So, what's your question? So the first step, okay, you must determine the indeterminate form. The second use the L'Hopital's rule. So this one is the same, yeah? It's the same. Theta approaches 0, tangent theta approaches 0, yeah? Theta approaches 0, theta approaches 0. So here is 0 by 0, yeah? Indeterminate form. Indeterminate form, so 0 by 0, 0 by 0, so in the indeterminate form, we use the L'Hopital's rule. So here, theta approaches 0, tangent theta prime, divided theta prime, yes? Theta prime actually is 1. Tangent theta prime actually is second square, yeah? Second square, what's the definition? Second actually is 1 by cosine, yeah? 1 by cosine, so here is 1 by cosine theta square, theta approaches 0. So the result is 1 by 1 square. So the result is 1. And for this one it's the same, okay, the same. So here first, limit t approaches 0, t times et. This limit is what? Is also here, this limit this part is 0, this part is what? Is 1. So 0 times 1, so 0, yeah? So here the denominator, t approaches 0, e1 minus et, yeah? E to the power t. So here is what? 1 minus e to the power 0. It's 1 minus 1, so 0, yeah? 0 by 0, so indeterminate form. So indeterminate form, so now we use the L'Hopital's rule. So here equal to what? So here this one equal to limit t approaches 0, this derivative, t et derivative divided by 1 minus et derivative. So here equal to what? Limit t approaches 0, this part, limit. This part,
t derivative.
t, first t derivative is 1 times et plus t times et prime, or et prime is et.
Yes.
So here this part is minus et. So here this equal to what? T approaches 0. So here is 1 plus 0 divided minus 1. So the result actually is minus 1. Yeah?
Yeah.
So I think it's easy, okay? So I think it's easy. Now let's see number 21, 22. 21, 22. Okay? 21, 22. So you can see actually in this class, okay, you do not have homework, yeah? You do not have homework. So I give you time to do the exercise on the class. So I think that you should do it up, okay?
Page 1.
x approaches plus infinity, x times psi pi divided x. This is the first one, okay? The second one is limit x approaches plus infinity 1 minus 3 by x. 3 by x to the power x. To the power x. For these two, okay? For these two. Now do the exercise, okay? For these two. For these two, okay? So u to the second one, to the second one. And u to the first one.
Which bit? Which bit?
So can you do it? No. So you? Yeah, you do it. So you do it. The first one. Can you do it? So who can do the first one? Who can do the first one? Hands up. The first one. So I think it's easy, okay? So who can do it? If you do it, I will give you more than 10 score on the usual score. The usual score, okay? So who can do it? Hands up. Yeah, hi. Very good, hi. Times 0.
prolific.
Here you can see infinity here times here is 0, so 0 times infinity, so I'm going to do it. Using the x like 1 times 1 like this. So do it yourself, okay? Cannot. And the what? So this means this is a function. We have one part here, okay? And this part and this part. And this way. And then, yeah. So times the Oh no, that's a good concept. You must be learning. So here you go. 0 times infinity, you can write it to 0 by 0 or infinity by infinity. So you must substitute write it to this form. Okay. Yeah. For this form, you use the numbers, okay?
So here, right, no, I'm not here. Say x times say pi by x. So this will go to here. Here is x times say pi by x.
X which is plus infinity, here is infinity times here is 0. So 0 times infinity, you must transfer it by 0 by 0 to infinity. And then you use the transform. Oh no. You know the method.
What you doing, bro?
Now. Okay. Come back and sit down. Okay, come back and sit down. So
semicolon.
Here, no, listen to me, okay, listen to me. Here, for the first one, here, x approaches plus infinity, yeah? Plus infinity, so this part is plus infinity, yeah? So this is plus infinity, and this part, pi by x. X approaches plus infinity, pi by x approaches what? Pi by x. X approaches plus infinity, pi by x approaches what? 0. Sin 0 is what? 0. So this is plus infinity times 0, yeah? So for this part, how to do it? Transfer it to 0 by 0 or infinity by infinity, yeah? So here for this one, how to do it? So it's equal to what? So it's equal to limit x approaches plus infinity. Here we write x by 1 by x. Yeah? So here is sin pi by x. Here is 1 by x. Yeah? So here you can see this part is what? This part is where x approaches plus infinity, this part is approaches 0. 1 by x approaches 0. Yeah? So 0 by 0. So here this is fx. This is gx. Yeah? So here for this form, you can use the L'Hopital's rule, okay? You can use the L'Hopital's rule. You cannot use L'Hopital's rule for here. You must transfer it to this form, 0 by 0, and then you can use the L'Hopital's rule, okay? So here this one equal to what? This one equal to limit x approaches plus infinity. Here, so this part limit, this part derivative, cosine, yeah? Cosine pi by x times what? Times pi by x derivative. So here pi by x is pi by x squared minus, yeah? So this is this limit. Divided here, this part derivative is what? Minus 1 by x squared, yeah? So here you can see here is a pi. So here the pi is pi right here. So here is minus 1 by x squared minus 1 by square. These two cancel it. So the result actually is what? Is limit x approaches plus infinity pi times cosine pi by x. Yeah? Pi by x approaches 0. So here cosine 0 is 1. Pi times 1. So the result actually is 1, is pi. So keep in mind, okay, 0 times infinity, you must transform. Transform it to 0 by 0 or infinity by infinity, okay? And then you can use the L'Hopital's rule, okay? So keep in mind, okay? And this one actually you can see here, x approaches plus infinity. 1 minus 3 by x. This one approaches what? 3 by x approaches what? 0, yeah? 1 minus 0, 0, yeah? Or 1 minus 0, 1, yeah? So here is 1, here is what? Is infinity. So here is 1 infinity, yeah? 1 to the power infinity. So how to do it? Not transform, take the lower, yeah? Take the lower on both sides, yeah? So here we can see we have what? First, we let y equal to what? Equal to 1 minus 3 by x to the power x, yeah? So then, take ln on both sides, yeah? So ln y equal to ln 1 minus 3 by x to the power x, yeah? Here, this x, we can take it out, yeah? So here equal to what? So here equal to x times ln 1 minus 3 by x, yeah? For this one, so here for this one you can see x. So we can see limit x approaches plus infinity ln y, yeah? Equal to what? Equal to limit x approaches plus infinity x times ln 1 minus 3 by x. So here this one is plus infinity. This one is plus infinity. This one is 3 by x is 0. 1 minus 0 is 1. Ln 1 is 0. So here actually is what? Is plus infinity times 0, yeah? Plus infinity times 0 is what? 0, yeah? So here is also, so how to do it? Transform it to 0 by 0 or infinity by infinity, yeah? So here equal to what? So here equal to limit x approaches plus infinity. Here is ln 1 minus 3 by x divided 1 by x, yeah? Here we write x by what? We write x by 1 by x, yeah? So here, this one go to here, yeah? So you can see x approaches plus infinity, this part approaches 0, this part approaches 0, 0 by 0, yeah? So here we can use the L'Hopital's rule, yeah? So the L'Hopital's rule, so here equal to what? So here equal to limit x approaches plus infinity. First, 1 by x, this derivative is what? Minus 1 by x squared, yeah? And this part limit derivative is what? Is 1 by 1 minus 3 by x. And times this part limit. This part derivative. 1 minus 3x, this derivative equal to what? Equal to minus 3 minus x squared. Yeah? So here is 3 by x squared. So here times what? Times 3x squared. So here we can see, here is, so we times x squared on both sides. So here equal to what? Here minus take out. So here is minus limit x approaches plus infinity. Here is what? Here is 3 times x squared on both sides. So here is 3 times 1 by 1 minus 3 by x. So here is what? Here is 1. Here minus, we take it here. So the result is what? So when x approaches plus infinity, this part approaches 0. So 1 by 1 minus 0, this part is 1. So here is minus 3. Yeah? Minus 3. So here means ln y approaches minus 3. So y approaches what? So y limit x approaches plus infinity y equal to what? Limit x approaches plus infinity e ln y. Yeah? Ln y approaches minus 3. So here the result is e minus 3. So these two, okay, these two, I will test, okay? I will test. So keep in mind, okay? Understand it. I will test. I will test in the usual exam, okay? So I'm sorry, the class is over. Okay.